In this video, we're going to look at the definition of a log function, why we need log functions, a method for rewriting exponentials and logs that always works, logs other than base 10 logs, and also base E logs. To introduce the concept of a log function, we start with the example graph f of x equals 10 to the x. This is an exponential function. So we pick some points, x equal 1, x equals 0, x equal negative 1. We plot these points. We get 0, 1, 1, 10, and negative 1, 1/10. And we get this L-shaped curve. And the graph takes off really quickly because it's a base of 10, not 2. Now we ask the question, does this have an inverse? Well, if you notice, I have the line y equal x plotted here in a green dashed line. The inverse will be a graph that's a mirror image across this line. Well, is the inverse graph, if there is one, is it a function? Well, if we do the reflection across that line, we get a graph that passes the vertical line test. Also, we had a horizontal line test with inverse functions that said if a horizontal line does not pass through more than one point of f of x, then f of x will have an inverse. And here, no horizontal line passes through more than one point of f of x. So f of x has an inverse. Now let's see if we can graph it. Well, as you remember, we can graph the inverse just by switching x and y around. So that's what I do here. I plot the point 1, 0. I plot the point 10, 1. And I also plot the point 0.1, negative 1, which is this point right here. And I graph the inverse function. It's a mirror image across that line, y equal x. And we get the L-shaped graph turned sideways. And sure enough, it's a function. It passes the vertical line test. So now let's see if we can find this function. Well, by using the procedure, we write y equal 10 to the x. Then we switch x with y and we get x equal 10 to the y. But then we have to solve for y. Well, we have no algebraic way of solving for y. But y is defined as log base 10 of x. So we write f minus 1 of x equals base 10 log of x. We even have a calculator key for base 10 log. It's the LOG key. If we take 4 and plug it in a calculator and do the log, we get 0.60. 4.60 is this point right here in red, and it follows our graph of the inverse function. We could have graphed the inverse by using our log function key on our calculator. In general, y equals the base a log of x is equivalent to a to the y equal x. And this is a really important relationship to memorize. And here's an example. Rewrite 95 equals 10 to the x in log form. Then use your log key on your calculator to find x. We rewrite this as x equal base 10 log of 95, and then we find the log of 95 on our calculator, and we get 1.978 rounded off, which is what you would expect because 10 squared is 100. You're going to have 10 to some power close to 2 that's going to equal 95. And we have no other way of solving for x other than using our log function. Here's another example. Rewrite x equal base 3 log of 81 in exponential form, then find x. Well, the base is 3, so we have 3 to the x equals 81. And we know that 3 squared is 9, and 3 to the third is 27, and 3 to the fourth is 81. So our answer here is x equal 4. And you're probably wondering, well, do I have a base 3 log key on my calculator? Well, the answer is no, you usually do not. But we have a way of dealing with this. We'll talk about it later. But here's something you probably want to remember. To rewrite an exponential as a log or a log as an exponential, just remember that the base of the exponential will equal the base of the log. The exponent of the exponential will be what the log is equal to in the log expression. And once you have those two quantities in place, there's only one place left for the third quantity. In the first example, we had 95 equals 10 to the x. Our base was 10, so it's going to be a base 10 log. Our exponent was x, so x was equal to the log. It was opposite of the equal sign. So we had x equal base 10 log of, and the only thing left there is 95, so we put 95 in that last place. In the second example, we had x equal the base 3 log of 81. Since it's base 3, the exponential is base 3. X was equal to the log, so that's going to be the exponent on the exponential. We have 3 to the x equals, the only thing left here is 81. It has to equal 81. So this works every time. 3 quantities all placed in the right place once you have the first 2 quantities in place. And what about bases that are not 10? Let's say we have x equal base 2 log of 15. What do? Well, we have something that's called a change of base formula that we're going to cover in a future section, but I'll give you the result of it right now just so you're not wondering. The change of base formula says we can write base 2 log of 15 as base 10 log of 15 over base 10 log of 2. We actually can choose whatever base we want in that ratio of logs, and we get an answer of 3.907. So that is one way we have of dealing with bases of logs that are not 10. And what about base e logs? If you have y equal base e log of x, we usually denote this as y equal ln of x, and ln stands for natural log. So we say y equals ln of x. Furthermore, there's usually an ln key on your calculator, just about always. If you have an log key, you have a key that's ln. Sometimes it looks like the word in, where what looks like in is actually ln in small case letters. And here's an example where we can use the ln key. Let's say we want to solve e to the x equal 100. We do this by rewriting in log form, and we have x equal the base e log of 100, and we can denote that as ln of 100 because that's what ln means. And using your ln key on your calculator, you should get 4.605 when you round it off to 3 places. So e to the 4.605 power is approximately equal to 100. And here's one last thing. The base 10 log of x is often denoted as simply log of x. The base is left off. So when you see no base, that means base 10. Here's a few examples. If we have log of 40 equal x, that's really the same as base 10 log of 40 equal x, which then if we rewrite it in exponential form is 10 to the x power equal 40. Here's another example. Log of 1,000 is the base 10 log of 1,000, and that will equal 3, since the exponential form of that is 10 cubed equal 1,000. So just remember, when you see log, that means log base 10. And also remember, as we mentioned earlier, when you see ln, that means log base e.